So, hi, good morning. Good morning, love.
Good morning, sir. How are you?
I'm good. I'm good. I'm great. Okay. And so,
Very
what?
interesting. Very interesting topic for today, sir.
Yeah, what is that?
Quantum computing and the effects
Oh,
on cybersecurity. Yeah.
oh, right. So, why this quantum suddenly, love? Why the
It's a,
sudden interest in
yeah,
quantum?
it's a sudden buzzword, sir. It's coming up, especially once after the AI is launched, and especially after that, a lot of buzzwording around quantum computing and the next steps, especially in terms of encryption, cryptography. So that's why I just wanted you to demystify about all this because. Especially newbies are concerned about these topics because they think that because these are not taught in the classes, that, so that's why I just wanted you to focus on them for a while.
Okay, I will explain this topic today with my two hands. Okay,
Sure. Sure.
right. So, otherwise, I would have gone to blackboarding, but an early morning podcast, my entire tech stuff is not there, so I don't want to activate that. So,
Yeah.
if you look at quantum computing, my interest with quantum started somewhere in class 11th, when I was in 11th, when we started doing differential and integral calculus. Okay.
Okay.
So once you did differential and integral calculus, the first thing I asked my maths teacher was, why are you teaching me this? D by dx, x tends to zero, integral, you know, something to something, x tends to something. So why are we doing this? What is the use of that in the practical world? Okay.
Right. Right.
Now that was something very, very intriguing to me that, okay, fine, it's nothing great, but what is its practical implications, right? So when I reached my master's, right, when I was doing my master's, and uh, I we had a class of quantum chemistry. Uh, that is the first time where I still remember Professor Bakshi, a very well renowned and very well respected professor from University of Delhi. Okay,
Hmm.
he started with a equation called Schrodinger wave equation.
Okay.
Now, that equation, when you solve, it tells you about the state of a particle which you can't see, which you can't feel, which you can just imagine. Light you can see, but you can't see the light particles, the photons. So how do you explain its state, right? So Schrodinger wave equation, solving it required a lot of integral and differential calculus, and that day I understood that what was the importance of understanding differential and integral calculus. Okay. Now, over a period of time, quantum mechanics and applications of quantum mechanics has come to a place where we can see its real life effects, though it has been there away from public eye. So if you look at nuclear science, right, that's completely dependent on quantum mechanics, right? If you look at studies of outer space, studies of dark matter, these are all quantum state related studies. Now, once we talk about quantum computing and its impact on cybersecurity, now this is where it becomes interesting, and we start discussing why. Okay, so firstly, you have to understand what is quantum computing and why we are worried. Why the science community or the cybersecurity community is, you know, worried about quantum computing. Now, you have to understand why quantum computing first. Now, if you look at digital computing, it depends on zeros and ones, means voltages. So, zero is denoted by some voltage, one is denoted by some voltage. And all your computer chips process these voltages to process your input and data, right?
Right. Right.
So that is the basics of how electronic circuits work. Now, once quantum computing comes in, you are depending on the quantum state of the particle. So if this is first quantum particle and this is second quantum particle and they are away from each other, now there is a relationship between these two quantum particles. The moment this quantum particle moves clockwise, the other quantum particle will move anti-clockwise.
Okay.
And
Okay.
by moving this, I can move the other quantum particle. That is the
Wow.
relationship. And
Wow.
you can segregate them in space and time.
Okay.
So you can keep these two particles anywhere and you can keep moving this, so your information will get. Okay. This is the basics of quantum communication, not
Okay.
computing per se. But what scientists have now developed it by using this basic science of two quantum particles, they are now, that means I can process information at a quantum speed.
Right.
Okay. So which is will be like way unimaginable from today's digital computing needs. So IBM Watson is one of the quantum computing. Now, to m- to, to deal with particles at quantum state, you need to go to very, very low temperatures.
Okay.
And that's why if you go on internet and YouTube and see how quantum computers work, they are, chilled with nitrogen gas.
Okay.
Okay, you can see that those quantum computers are really, a lot of pipes are coming through because a lot of nitrogen is being supplied to keep the temperature at minus 273 Kelvin, where you can actually, deal with a quantum particle.
Wow.
So if that is the science involved, you are looking at, can this huge room sized computer can now miniaturize and become a laptop 20 years from now, right? Or 30 years from now, or 10 years from now.
Yeah.
Fine. If that can happen, then what? That means today's cryptographic algorithms, which are majorly in use, AES, okay? For example, AES 256, if you want to break AES 256 by brute force, it will take you billions of years with today's computing speed.
Right.
Okay. And that's why if I have anything which is encrypted with AES 256 today, it's of no use billions of years because I won't exist, right?
Right.
So, so today's computing speed cannot break AES 256 in a brute force manner,
Right.
right? Also, AES as an algorithm does not have, as of now, any bypass. Means that means nobody has been able to crack the algorithm logic
So far. So far. Yes. Yes. Yes.
so far, right?
Yeah. Yeah.
So the only way you can crack a cryptographic algorithm is by brute forcing, as of now,
Yes.
which is where the logic has not been broken. The only way you can break any algorithm is by brute forcing, trying all kind of keys which are possible. Okay, so that's why we are talking now about post-quantum cryptography. We are saying that since internet is a public network, hackers and bad elements can some way get hold of your encrypted communication and are presently storing that information in their storage archives
Right.
and waiting for that day when quantum computing comes, wherein a lot of information can be decrypted. So you are saying that is first thing is your today's information may become publicly available 10 years or 20 years from now. That may not be a large concern, right?
Right.
But what you are saying is that since quantum computing is in vogue and companies are researching, we take into action that in very near future time, you will have public quantum computers available.
Right.
Like today, if you go to AWS, you have high performance computing, which you can rent from AWS
Okay.
or from Google. Okay.
Yeah.
Even IBM gives you access to its quantum computer.
Okay.
Okay. So that means organizations are building quantum computers, making it available for you to try stuff. So it may not be available to general public. It is available to science communities of science who want to process a lot of data. But there will come a time when you will have public high performance computing based on quantum computers available in the public. And then you
Mm-hmm.
are worried that at that point and if you do not do your due diligence now and start developing post quantum cryptographic standards, post quantum cryptographic algorithms, post quantum cryptographic libraries in your processes right now, you might get left behind when tomorrow quantum computing becomes available publicly, right? So imagine that you are still working on AES 128 for your bank, and another 10 years from now, you do not upgrade. You says, oh, AES 120 is good enough for me. And suddenly after 10 years, you realize that the quantum threat is there on you and your entire systems are super vulnerable to brute force decryption.
Mm-hmm.
Right. So that's why the scientific community is saying start thinking about post quantum cryptography right now. Now, if you look at certain organizations, they are proactive. Look at what iOS has done. Apple has done. Apple has developed and deployed post quantum cryptographic solution on its FaceTime messaging, just as a probably initial primer, right?
Okay.
Thinking that if today we deploy post quantum cryptographic algorithms, our communications is safe in the quantum era. right? So that is the logic, and a lot of people, there's a lot of science buzz going around. NIST has already come out with post quantum cryptographic standard. Okay.
Wow.
Yes, and there are two algorithms right now available for post quantum, which you can deploy on your applications, right? And there's a lot of research going on in the post quantum, cryptographic solutions. I know a lot of companies. One of my friends, very good friends, he is the CEO of a quantum uh, computing company. Okay,
Mhm.
and they have a lot of products. And then there is a company called QNew Labs, which is working on this for quite some time. It's going to have a lot of applications in national security, in defense applications as we go through. Okay, in financial sector also, it will have a long term impact.
Can I say that then it will basically, maybe change the entire landscape for cybersecurity?
It will change the landscape for cybersecurity professionals who deal with, definitely with encryption, of course. And encryption
Yeah.
is one of the major controls for all cybersecurity and information security professionals.
Right.
And today
Right.
we close our eyes and say AES, AES, AES,
Yeah.
okay, or RSA or AES. So the 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 the, the cryptographic community is definitely worried. They are aware of that. The cybersecurity professionals who openly use those libraries like AES 128, 256, or 192, or RSA applications will probably have to start thinking 10 years from now, 15 years from now, what are the threats and what is that proactive approach which they would like to incorporate over a period of time.
Okay. Okay. And how much probability of this happening you think is realistic? Because if you remember, sir, we all also had a previous case where we had a virtual reality thing as well, where had people started putting on glasses and all, just to have a VR thing in mind. But then suddenly it stopped in between. Somewhere now it's gone.
No, so see, love, every technology has a high and a low. Okay.
Right. Right.
If you look at AI has gone through a lot of winters, AI winter. Okay.
Yeah.
Uh,
Yeah.
and now we see the possibility of AI. You see that?
Yes.
So it is
Yes.
not, AI research is not happening from today. AI research has been happening from 1950s, 1940s, as early as 1920s, right?
Right.
Scientists
Right.
have been discussing artificial intelligence, and there has been a lot of research which has gone in how human mind works. And based
Mhm.
on that, over a period of time, algorithms have been developed,
Right.
right?
Right.
So if you see how neural networks work, how, so they are all replicas of human mind.
Right.
And there are beautiful books. Okay, I had a books called by Mr. Minsk. Okay, artificial intelligence and the science of brain. It explains human brain in a very very simple manner. So so based on those logic, the algorithms have come to this place, and the GPU computing has enabled today the AI sciences to develop much higher, right?
Right.
So if you
Right.
look at VR also, some to some uh, extent, VR has come into your life. May not be a direct glasses, but you look at Apple developing its glasses pro. Facebook is high on its glasses, so it is a technology in development, and it'll definitely come in. It's no doubts about it. Now, when we talk of quantum computing, these were all theoretics where we said that it will get brute force. But you look at China. China has proven, okay, using their quantum computing, they broke a 20-bit AES encryption.
Wow.
Okay, 20-bit. They didn't go to 128-bit. They broke AES at 20-bit. Though AES comes as a standard only 128-bit, 192-bit, and 256-bit. So with today's quantum computing, they broke a 20-bit encryption, right? They brute force 20-bit encryption. So if today it is 20-bit, and with Moore's law, how much time it will take to reach 128-bit, right?
Right.
So
Right.
every year, Moore's law was the computing speed will go by 2 times, right? But now I think computing speeds increases by 2 times every 6 months.
Definitely, sir. Yeah. Or even
So
shorter than that in some cases.
yeah,
Yeah.
even shorter than that.
Yeah. So, what can organizations do right now, sir, to prepare for themselves for this upcoming change? Because I'm sure that startups would not have so much of budgets and all to prepare for quantum related threats,
So
but big companies definitely can, right?
So you have to do again. So I always say, your security logic, security decisions are driven by risk management. You have to
Right.
understand risk. So Apple understood its risk and it implemented a solution, right? Similarly, the
Yeah.
banking sector has to. I think the BFSI sector, the critical sectors, the bigger companies, right? They should be looking at and start adopting post-quantum cryptographic techniques to at least start off. Okay, say they realize, okay, this part is as of now something which we should try and have a test bed to start trying out quantum computing, post-quantum threats and evaluate them, and let's see if your post-quantum threats can be tackled today, and that would become part of a proactive thinking for cybersecurity.
Right. Right. Right.
See,
And
adoption makes anything cheaper, right?
yeah.
To-
Yeah.
I will say 20 years back, a thin TV used to cost, 50,000 bucks for a small, monitor sized TV. Okay, and today you can get a 65-inch flat television for the same amount of money.
Yeah. So would there be standards again related to sir quantum when it comes?
Standard adoption is very, very important. So NIST has already come up with NIST standards for obviously
Okay.
US centric federal agencies. You
ISO
will
would also
see.
come up with something then. Yeah.
Yes, so global
Yeah.
standards will start coming. We do see global and regional standards will start rolling out in another 2 to 3 years' time, because it's gaining pace. In India also, DSCI is leading a lot of effort on post quantum, efforts. Uh, I'm aware of the scientific community, which is doing their work in that space. And somewhere down the line, I feel AI and quantum computing will gel over, because for developing AI algorithms, you will require quantum speeds, quantum computing speeds. So AI and quantum will gel together.
Okay. And one more thing is that how can organizations ensure that they are updated on the latest advancements in terms of quantum computing and encryption?
I feel, it may not be possible in small companies or even mid-sized companies, but I somehow feel, in today's world, all large organizations should have uh, a core knowledge group, you know, which should have discussions and should generate knowledge banks, and good organizations do that, right? So research is one good thing in any organization. You should actively research uh, about how business can grow, what are the business threats. So having I will say, a core knowledge bank or a core knowledge group, okay, which keeps its eye on evolving technologies, evolving threats, how business organizations can progress further, is a good step to have.
And one more thing, sir, will this quantum computing affect the compliances and regulatory requirements as well in terms of, what we have today?
If the threat becomes persistent, then compliance becomes mandatory. I say
Yeah.
that. If the threat
Yeah.
is persistent, right? Then then once threat is persistent, then you have an enemy. If you have an enemy, then you have to safeguard yourself. And if you have to safeguard yourself, some regulator will come in. And once the regulator comes in, compliance becomes necessary. So somewhere down the line, yes, evolving threat will catch the eye of the regulator, and we will work in that direction.
Okay, okay. And a lot of leadership teams watch our podcast. So, if I am a leader of a company, let's say I'm a CEO watching, or I'm a CISO watching, or CIO watching this video, what is my role in terms of quantum readiness for my organization? What are my next steps?
So I should not see quantum readiness only in terms of security threat. I
Okay,
should see quantum adoption as part of business enablement, right?
okay,
So
okay.
if I'm an organization who can dedicate a little bit of budgeting for future technologies, keeping an eye on how my business can grow in the times of how technology is evolving. Okay, so I'm very sure that all organizations today value AI, right? A
Right,
small company like mine, I'm trying to find ways to reduce my workload using
right,
AI tools, whether
right,
it's graphics, content, research. A lot of time is saved today by just using ChatGPT to make a proposal. You know,
right.
there was a time when I used to make proposals for companies sitting on the laptop typing. Today, I say, listen, I need to give a proposal to, uh, you know,
Say
so
X,
there's a
Y,
lot
Z.
of
Yeah,
so
whatever.
it's probably a spammer, right?
Yeah, it's a scammer. Yeah.
Yeah, yeah. So scammers will be there everywhere.
They are waiting for our podcast to come online. Yeah.
Right. Yeah, great. Thanks, D Queen. Keep scamming, keep spamming. Right. So you have to live with them, right?
Yeah.
So organizations, I feel, have to adopt to growing technologies. Otherwise, you will be left redundant. There's no there's no second doubt about it, right? Today,
Mm.
organizations which are adopting, uh, you know, AI will definitely go past organizations who are not adopting to AI. That's one simple thing, right? So
Right.
I feel that you have to adopt to quantum computing and quantum cryptography and quantum security at some point in time, and you should be thinking at it.
Yeah.
Because if you're not, then you end up
Mm.
spending a lot of money when the water comes on your head. So
Yeah.
a stitch at time saves nine.
Right. Are there any specific industries which are more vulnerable in terms of quantum?
Those who are on the public domain, imagine who, firstly, government organizations, I feel, who
Yes.
hold a
Yes.
lot of data, organizations dealing with biometrics, organizations dealing with privacy information, who are still using pre-quantum era algorithms. Okay, organizations who have a lot of banking information, finance, economy will definitely be a major concern. So I feel mainly the financial sector, privacy sector, okay,
Mm.
and critical sectors is what I look at, more towards the quantum space initially.
Okay. Okay.
Privacy,
And
therefore, privacy,
yeah.
therefore, becomes somewhere down the line. Yeah.
Okay. Okay. And so could quantum computers also compromise blockchain technologies? Because definitely they have power, right?
Uh, can you please come again? I was deleting the comment of this
Yeah. Yeah.
spam. Yeah.
Could quantum computers compromise blockchain technologies as well?
Oh yes, blockchain. Blockchain right now is riding on completely on symmetric and asymmetric computing, right? Asymmetric algorithms. So quantum computing puts blockchain under an immense amount of risk.
Yeah,
Immense amount
definitely.
of risk. So now
Definitely.
so if you look at blockchain, it derives its, I will say, one of the major security, it derives from nodes, right? So, and anybody can deploy a node today in blockchain, right? If you have high speed computing, if you have GPUs, you can deploy a Bitcoin node and start hashing. Okay. So now now the quantum computing has the power to take on all the nodes simultaneously. Okay. That is the quantum speed, right? So today, if I want to attack Bitcoin nodes, I will require a lot of computing, which probably is not available. Okay,
Right. Right.
because there are numerous amounts of nodes and you cannot launch a dedicated attack on all the nodes together. Quantum computing makes it possible.
Right. 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 So you mentioned, sir, the role of risk assessment in making sure the quantum risks are assessed for an organization. But I have seen, again, this is my personal opinion, in some organizations the risk assessments are not properly done. So what do we do in that case? If there is a lack?
So, love, I feel over a period of time, risk management was already always talked upon in the financial space majorly, because all
Right.
organizations were worried about financial risk, and they had some pretty good frameworks to manage those risks. Okay, I feel uh, today we also have very good frameworks for managing risks in the information security and the cyber security space, right? And one of the two major frameworks which help you in a proper risk management is probably ISO 27001, supported by ISO 37000, 31000, and 27000. And
Yes,
another good framework is NIST SP 837. Another
definitely.
enterprise framework is SAPSA, right?
Yeah,
Okay, and maybe COBIT.
yeah.
So these are the four b- major frameworks which are adopted by organizations. COBIT is a major framework adopted by uh, corporate organizations. NIST SP 837 majorly adopted by US federal agencies and contractors who are dealing with US agencies. ISO 27000 majorly in the EU and the APAC and the Asia region. So ISO is one of the major factors. And to be frank, if you look at any major framework that's evolved from ISO, so somewhere down the
Okay.
line, all frameworks are built upon ISO. So
Right.
NIST took a lot of material from ISO and developed their own. Uh, NISA took a lot of knowledge from ISO. RBI took a lot of knowledge from ISO. ASD, Australian Signals Department, took a lot of knowledge from ISO, and everybody has developed frameworks because ISO was a common framework agreed upon by the world. So
The
somewhere down the
starting
line,
point. Yeah,
yeah,
the
starting.
starting point.
Yeah.
Yeah. And how might this quantum computing impact the military and defense sector, sir?
Oh, that's a very very viable question. So quantum will have major effect on your national security and defense applications majorly. If I am a enemy state having quantum computing capabilities, I would rather like to launch an attack on your networks using quantum computing force than launch a kinetic or a physical attack. So probably organizations, national security organizations are already looking at that, should be looking at that, and looking at post quantum era threats because uh, today the entire world is networked. To be frank, so you have a network, you can penetrate your enemy's core networks and can launch an attack. So probably defense and national security apparatus will be more alive, should be more alive to quantum threats and adopt quantum precautions or quantum preventions, quantum attack preventions uh, at an earlier stage. And keep an eye
Right.
on its enemy state as to what is the development pattern in their case.
Right. Because they
You should always
definitely
keep
when,
a you
yeah,
should always keep an eye on your enemy, no matter what.
because definitely he has the upper hand if it has that. Yeah.
Whosoever is your enemy. I'm not an army anymore, so I don't play judgments. So if so, I don't play judgments, right? Because a lot of judgments are political. So and I'm
Yeah.
not in that space. So I
Yeah.
look at from a technological point of view that okay, if I'm trying to protect a organization, I should keep an eye on my enemy. I should keep an eye on my threat, and from there, that's where threat intelligence and threat hunting, as a concept comes in.
Right. Right. Sir, Rakesh has a question.
Yeah, so Rakesh says, so does that mean using a quantum computer, we will be able to attack a blockchain? Theoretically, as of now, yes, because ultimately the entire blockchain is on the network and uh, we're looking at quantum speed. So if you look at quantum speed is, if you today want to judge the capability of your laptop and the complete computing capability of the entire world, you can sum it up with one quantum computer, Rakesh. That's the capability. So if quantum speeds reach that level, the entire computing speed of the world can be packed into just one quantum computer. Okay, I can explain to you that scientifically, but that will take a lot of time, right?
Yeah.
Because just two quantum particles, can achieve unimaginable quantum computing speeds.
Yeah. And sir, if AI and quantum come together, then what?
Both good and bad. AI ultimately will come on quantum. There's no doubt about it.
Yeah.
Right. AI will definitely, because today AI depends on GPUs, and GPUs
Yes.
are digital devices, digital, electronic, and electrical, a lot of electrical and electronic. So if you look at a GPU, okay, I built a AI application way back in 2018. I bought two NVIDIA GPUs, and we created a digital vision, right? So there were a lot of vision LLMs available. So we were trying to work something to have automatic threat detection using visual, LLMs. So at that time, we were finding it very difficult to run the algorithm and train the algorithm on just two GPUs. We needed at least 10 GPUs to effectively train. So now 10 GPUs were costing me at least 20 lakhs and would have occupied space. Then I need heating arrangement, cooling arrangements, and then I need power. So if you look at GPU farms, all AI farms, you will see thousands of GPUs, stacked. If you go to OpenAI's lab, you will see thousands of GPUs stacked and working at the back end too. That is where once quantum computing comes in, they will replace the GPUs. I have no
Okay.
doubt about it. So the moment they replace the GPU, one small simple laptop might be able to run the complete AI applications of the world.
Right, right,
And
right,
you look at why IBM, why Google, why Apple, everybody's working in developing quantum computing. They're spending huge
yeah,
amount of money in developing, and they have already developed
right, right.
in the primitive stage, of course. But yes, they have developed, and you have access. You can get access to IBM's quantum computer.
Watson, you call it, right?
Watson is the AI computer. I'll have to check up. I don't remember,
Okay, okay,
but
okay,
IBM has made it available for public
okay.
access, but not you cannot. Public access means some educational institution wants to carry out,
Ah,
run some
that way,
tests.
that way.
Yeah,
Okay, okay,
right.
okay, okay, okay. Good. That was more or less, I think, from my side. Anything else you want to add?
No, so today I wanted to take it a slightly more technical, or maybe
Yeah,
slightly more futuristic, discussing quantum, because not
yeah,
everyone gets a chance to discuss it in a public forum. It happens in a lot of closed door forums. I said,
definitely.
okay, fine, let's share some knowledge on quantum computing and quantum threats, right?
Yeah. One thing I would definitely like to add here, so like you mentioned the importance of risk assessment and risk management in any organization, because if you're not sure about what all risks you have in terms of threats and vulnerabilities of your current assets, it's kind of very difficult to imagine or portray whatever is upcoming in your organization, right? So
Yeah.
definitely make sure that your risk identification is your topmost priority. That is one thing I would definitely like to add, sir. Yeah.
Yeah, for risk management professionals, of course, they need a dual sense approach, that they need to look at the rising
Yes.
risks. They also need to understand the technologies over a period of time, right?
Yes,
And
yes,
you will not find some professionals who have the complete technical knowledge. Of course, it's not possible. You have to work a lot in the industry to gain insight into every risk, right? So it's good to have a lot of knowledge by reading, by understanding various kind
right,
of risks. You have to keep updating yourself over a period of time.
right, right. That's it, sir. I think from my side.
Right, right. Well, yeah, okay, let's keep it short and sweet, and let's get ready for the day. Right. Thank you, guys. Thank you, everyone, and see you next time.